Hello guys, welcome back to my channel Gamma Digamma. And in this video I thought to myself, let's do a topic in differential equations. So let's get started. Okay, so when we talk about linearity, we have differential equations of this form: dy over dx plus a function of x, p of x, times y is equal to q of x, another function of x. And this differential equation is what we call linear in y. How do you identify such differential equations? Well, you just look for like a lone survivor r, lone survivor y, like this. But this is linear in y. What about linear in x? Differential equations of the form dx over dy plus some function of y this time times x is equal to some function of y. This is linear in x because now see there's a lone x over here. And how do we approach these differential equations? Well, let's look at this, how to approach this one, the first linear in y, because the method is going to remain the same even for the linear in x. So what you do is you multiply all sides by this factor e raised to integral of px with respect to x. This may seem a little non-intuitive at first, but trust me, it's gonna help us a lot. Okay, some places I've written p, just p, that's p of x. Okay, now the best thing is noticing that this expression entirely, the sum of two terms, is actually the derivative with respect to x of y times this guy, e raised to integral of p of x dx, because it's actually the product rule. If you do the product rule on this guy, so first if you differentiate y, you get this and keep the second guy the same, you get the first term. Then you differentiate this e raised to integral of p dx, and this is precisely what you get. And you keep the y same, you get this exact term by using the chain rule. So that's nice, and that this is equal to q of x times e raised to p of x dx. Now what we can do is we can integrate both sides with respect to x, and by the fundamental theorem of calculus, the antiderivative of a derivative is just the function itself. So we get y times e raised to integral of p of x dx. That's equal to, well, this is just going to remain the same, q of x e raised to integral of p of x dx plus some constant of integration c, because it was an indefinite integral. And so if you divide everything by this factor that we originally multiplied, you get y as the solution. And by the way, this factor that we multiplied here, this factor of e raised to integral p of x dx, in the linear in x case it will be integral of py dy, but this factor is what we call the integrating factor. It's essentially responsible for completing the product rule of differentiation. And once we identify this as a product of derivatives, we can just take the antiderivative on both sides and end up with a general solution in y. Okay, and you can repeat this process for linear in x except the integration factor will change. It will become e raised to integral py dy. This will be dx dy, and make changes accordingly. You get with a similar thing. Okay, so but this is still like baby stuff. I mean, this is what I would call high school level stuff. Let's move on further to a little more advanced concept. Okay, what if we have a differential equation of this form, dy over dx plus p of x times y is equal to q of x times y raised to an arbitrary number n. And I would just like to use a little more compact notation. Dy over dx can be expressed as y prime. This is Newtonian notation, and it truly saves time. Okay, what if we have something like this? Now what I'm going to show you is called Bernoulli's method. So what you do is you divide both sides or multiply by y raised to negative n on both sides. So when we do that, we have y raised to negative n y prime plus p of x times y raised to 1 minus n, just the exponent property, and q of x times y raised to 0, which is 1. Fine. Now here's a $1 million observation. Here's the most genius observation ever. I mean, you could only multiply by y raised to negative n only if you knew this observation, but in any case, this is a genius observation. Notice that this first term over here is the derivative with respect to x of y raised to 1 minus n. Of course, you divide by 1 minus n, because if you try taking the derivative of this guy, you end up with 1 minus n, which cancels out with the denominator, and you get y raised to negative n. You subtract a negative, you remove a 1 from the power, times y prime by the chain rule, which is precisely this first term. So the first term is 1 over 1 minus n times d over dx of y raised to 1 minus n plus p of x times y raised to 1 minus n is equal to q of x. Fair enough. Now let's do like a quick change of variables. So let v equal y raised to 1 minus n. We have 1 over 1 minus n times dv over dx now, plus p of x times v is equal to q of x. And notice what we have. We have a linear in v, except let's just like shift this factor over there. So dv over dx plus p of x times 1 minus n times v is equal to 1 minus n times q of x. Now this is truly a linear in v, and the integration factor is going to be I don't know, let's call it f of x. Maybe f of x is the integration factor e raised to integral of p of x times 1 minus n dx. So if we multiply both sides by the integration factor, we just get a f of x dv over dx plus f of x times p of x 1 minus n v is equal to 1 minus n q of x f of x. Now this is just like before. We just converted like a non-linear differential equation to a linear one by Bernoulli's method, and now we're just solving the linear one. And this is, if you recall the definition of f of x, it's just the chain rule. You have to just use the chain rule, or the product rule in this case. So this is going to be d over dx of f of x times v, that's equal to 1 minus n q of x f of x, and then antiderivative both sides, 1 minus n q of x f of x plus constant of integration c, and v is finally v, which was y raised to 1 minus n, is indefinite integral of this guy divided by f of x. So y is finally, I'm just going to sub f of x in. F of x was, I believe, let's see, e raised to integral p of x 1 minus n dx. I forgot the dx in places here. Dx here. Dx here. Plus c divided by e raised to integral p of x 1 minus n dx. But now we just took the inverse root of that, so 1 over 1 minus n. That is what I like to call the general solution to a differential equation of this form. You can call this a Bernoulli differential equation, but whatever. Okay, so now let's actually apply this. Let's do some examples. Okay, we have y prime plus y is equal to e raised to x times y cube, and we know that y of 0 is 1 over square root of 3. They're telling us to find y of 1. Fine, they've given us initial conditions and a differential equation. Let's try solving it. Let's divide by y to the negative, or multiply by y to the negative 3 on both sides. So we have y raised to negative 2 here, and we have e raised to x here. Now notice that this first term is actually minus 1/2 times the derivative with respect to x of y to the negative 2 power plus y to the negative 2 is equal to e raised to x. Now let's do a change of variables here. Minus 1/2 dv over dx plus v is equal to e raised to x. Let's get rid of this negative 1/2 factor here. So negative 2v is equal to negative 2 e raised to x. And this is linear in v. So we need the integration factor. So integration factor is going to be e raised to integral of negative 2 dx minus 2 integral of e raised to negative integral 2 dx times v is equal to negative 2 e raised to x e raised to negative integral 2 dx. Fine, and notice like the first guy is just the derivative of this guy. When we can evaluate this to be e raised to negative 2x times v, that's equal to negative 2 e raised to x e raised to negative 2x. Now antiderivative everywhere. We have negative 2 integral of e raised to negative x dx plus constant of integration. E raised to negative 2x v is equal to 2 e raised to negative x plus c. And v was just, let's see, y raised to negative 2. And we can basically flip the, do like a invertendo here. So we have y is nothing but square root of e raised to negative 2x over c plus 2 e raised to negative x, which you can write as a bunch of positive powers in the denominator. So 1 over c times e raised to 2x plus 2 times e raised to x. But we know that y of 0 was 1 over square root of 3. So if we sub 0, we have 1 over c plus 2, which means that c is 1. So we finally have our general function for this case. 1 over e raised to 2x plus 2 e raised to x. Fine, and they're telling us to find y of 1, right? Fine, that we can do it. E squared plus 2e. That should be the answer. So you see, this was a Bernoulli differential equation with n equals 3. P of x was 1, luckily in this case. That's why the integration factor was so nice. And q of x was e raised to x. Okay, moving on. Okay, so here's question 2, and for this guy I'm just going to directly use the formula. So it says y is equal to integral of, well, n is 3. Let's just write these things. N is 3. So we have negative 2 here. Q of x is this guy actually, which on the other side. So that's 4x plus 5 squared divided by 2 cosine of x, and then has the integration factor inside, this big integral, e raised to integral of p, which is 1/2 tangent of x, and 1 minus n, which is in our case going to be negative 2 dx plus c, divided by e raised to 1/2 tangent f of x times negative 2 dx, but raised to 1 over negative 2, or negative 1/2 power. So y is going to be, well, the 2's will cancel out definitely. I believe we have a negative here. 4x plus 5, the whole thing squared. This will give negative. Integral of tan of x is negative natural log cosine of x. That negative, this negative will make a e raised to natural log of cosine of x. And we still have a cosine here in the denominator. Let's not forget that. Dx plus c divided by, again we have the same, e raised to natural log of cosine of x raised to negative 1/2 power. So now we can like simplify this, because e raised to natural log is sort of going to cancel out. We just have cosine, which cancels out with this cosine. Negative integral of 4x plus 5 squared dx plus c divided by cosine of x to the negative 1/2 power. And integrating this is pretty easy. We have negative 1/12. I'm just reversing the power rule. Negative 1/12, 4x plus 5 to the 3rd power plus c, everything divided by cosine of x. But even that is raised to the negative 1/2 power. That's why. That's the general solution. Fine. This was using the formula. You could have done this without the formula in the analytic way that I showed you last time in the question, example 1. Okay, so here's the last one. Let's do it in an analytic way. Now notice that this first term is just negative 1 over 1 times the derivative of y raised to negative 1. Keep the second term as it is. Fine. Okay, you can do like a variable change. V is equal to y raised to minus 1. So we have negative dv over dx plus v over x is equal to x times natural log of x, which is again going to be linear in V. Let's just get rid of this negative sign first. So the integrating factor this time is going to be e raised to negative dx over x. That's because that's the things apart from the v. dv over dx minus e raised to negative integral dx over x. V over x is equal to negative x natural log of x e raised to negative integral dx over x. Notice that this entire thing on the left hand side is just the derivative with respect to x of e raised to negative integral dx over x times v, and negative x natural log of x e raised to negative integral dx over x. Well, we know integral of dx over x is natural log of x. With a negative, that will become natural log of 1 over x, and that is in the exponent of e, so that's just going to be 1 over x. So we just have v over x here, and I am taking the antiderivative simultaneously. So I have antiderivative x natural log of x, and this just turned out to be 1 over x as we discussed before, dx plus constant of integration c. The x's will cancel out. We have v over x is negative, let's see, okay, so we have the integral of natural log of x, which you can do by integration by parts. So you get x times natural log of x minus x plus c, fine, whatever. So v is just going to be what, negative x squared natural log of x plus x squared plus cx, but v was just y raised to negative 1, so you can just take a reciprocal everywhere. Y is 1 over negative x squared natural log of x plus x squared plus cx. That's the general solution. Okay, so I really hope you enjoyed this video, guys, because I think this is a really important topic, and like and subscribe to my channel, and stay tuned for more content. Peace out.